Good morning, girls. We know what are the main factors affecting the rate of a reaction. We already discussed about concentration of the reactants, then effect of temperature on the reaction rate. Okay. So today is effect of catalyst. How catalyst is influencing on the rate of a reaction. Okay. So what are catalysts? Catalyst means it is a substance that alter means change. It is a substance that alter the rate of a reaction without consuming or without undergoing any change during the reaction. Okay, catalyst means what? That substance, it alter the rate of a reaction, but itself it does not undergo any chemical change and it will not consumed during the reaction. After the reaction, we can recover a catalyst. Clear? So catalyst means it is a substance that alter the rate of a reaction without consuming or without undergoing any chemical change during the reaction is known as catalyst. Clear? Here you can see in this reaction KClO3 potassium chlorate, MnO2 is using as which one? The catalyst. Okay, so this MnO2 will alter the rate of a reaction. Clear? So the influence of this one catalyst on rate of a reaction is explained using a theory that is given here. Intermediate complex theory. What is the name of the theory? Intermediate complex theory. Okay, according to this theory, the catalyst molecules, the catalyst react with the which one? Reactants. Okay, the catalyst react with the reactants to form an intermediate complex. What first? The catalyst react with the reactants to form an intermediate complex. That intermediate complex is very unstable, that is highly unstable, okay, and it will dissociate to give the products and catalyst we can recover. Okay, nothing is there, the catalyst react with which one? First our reactant, and it form an intermediate complex. That intermediate complex is which one? Unstable, and this intermediate complex dissociate to form which one? Our products, and we can recover the catalyst. Okay, so we can explain this using a graph. It is here potential energy against which one? Reaction coordinate. Reaction coordinate means how the reaction is happening, improvement of the reaction. It is here. This is potential energy. Here you can see two peaks are there or two curves are there, right? This is the one, okay, and this is the second one. Okay, here this one, the first peak, this is in a white mark, no, that curve is without a reaction, without which one? A catalyst, or in the absence of a catalyst. Okay, so you can see this is the curve, and this curve need what? More activation energy to a reaction to occur. Okay, in this one it is required which one? More activation energy for the reaction to occur. Here you can see here, this is the reactant, it gives the products, but after long it is taking more time also, and it is required which one? More activation energy without catalyst. It is in the absence of catalyst. Okay, so here it is marked, this is the which one? Activation energy. This gap, this is from this first curve, this one. So this much amount of EA means what? Activation energy is needed for this reaction, that is without which one? Catalyst. Okay, but you can see here the second curve is there. That second curve is peak is very small, and the activation energy, this much only the activation energy. Okay, so the activation energy for this reaction is what? Less compared to without catalyst. This is with catalyst. Okay, so what we can realize from this both curve is this catalyst reduce the activation energy for the reaction. That means this catalyst will provide a new path for the reaction. Okay, and it will increase the speed of the reaction or rate of the reaction by reducing the activation energy. That means, for example, if you want to go to Kayarpuram, okay, two roads it's there, you can select which one, the direct path or which one, any shortcut. So here what is the catalyst? Shortcut if you are taking means what will happen? You can save the time, you can save the energy, right? So here catalyst what it is doing is, it is selecting the which one? It is selecting the path which what? Less activation energy, or it is selecting which one? The shortcut. So the reactants, they will react. Okay, easily we can get the products without without taking lot of activation energy. That means the catalyst will provide a new path for the reaction. That path means with less energy and less time. So what will happen? Automatically the rate of the reaction increases. So catalyst means it will provide a new path for the reaction. So that is why we can reduce the activation energy, and the reaction, the speed will also increases. Some catalysts are there. They will reduce the speed of a reaction. That catalysts are known as negative catalyst or inhibitors. What is the name of that catalyst? Negative catalyst or inhibitors. What they are doing is, these catalysts react with the reactants and form intermediate complex, just like I explained, intermediate complex. But that intermediate complex is very stable. Usually what is that? In catalyst using means the intermediate complex formed will be unstable and we will get the products immediately. But here, if the inhibitors or negative catalyst if you are using means, what will happen? The intermediate complex it formed will be, the catalyst form a strong intermediate complex with the reactant, and we have to supply more energy to break that complex, and what will happen? The speed of the or the rate of the reaction, what is that? It reduced. It reduces because we have to supply more energy, activation energy, to reduce the intermediate complex. So that is why what is happening? The rate of the reaction decreases or reduces. If you are using a catalyst, what will happen? The rate of the reaction increases because the catalyst select a new path for the reaction with less activation energy. So we will get the products easily. So clear all of you? Next I want to do problems based on Arrhenius equation. Already I told you, based on Arrhenius equation, problems are compulsory. So the first problem is, if the rate constant for a reaction is 1.6 into 10 raised to minus 5 and 6.36 into 10 raised to minus 3 per second. Rate constant at two different temperatures are given. We know Arrhenius equation we already derived at two different temperatures. Okay, at 600 Kelvin and 700 Kelvin. So at 600 Kelvin it is given 1.6 into 10 raised to minus 5, and at 700 Kelvin it is given 6.36 into 10 raised to minus 3. Okay. Calculate the energy of activation or activation energy. We know the main function of Arrhenius equation means it helps to calculate the activation energy. So we have to write the equation at two different, Arrhenius equation at two different temperature. We know that log K2 divided by K1 equal to EA divided by 2.303 or T2 minus T1 divided by T1 into T2. Here K2 means rate constant at temperature T2, K1 means rate constant at temperature T1, EA equal to energy of activation or activation energy. Then R equal to gas constant, T2 is the second temperature, T1 is the first temperature. So we will substitute K2, it is already given 6.36. Okay, so 6.36 into 10 raised to minus 3 divided by K1, it is 1.6 into 10 raised to minus 5 equal to EA divided by 2.303 or we know 8.314, which is a constant, into T2 at temperature, second temperature is 700 minus 600 divided by 700 into 600. Actually T1 means 600 into 700. I wrote 700 into 600. It is not a problem. After solving this part, log 6.36 into 10 raised to minus 3 divided by 1.6 into 10 raised to minus 5. After solving this, we will get log 397.5. Log 397.5. Log 397.5 equal to what is the value? 2.5993. Okay, you have to take the logarithm table and you have to find out in electrochemistry chapter. And last year also I explained how to take the log. Okay, so log 397.5 equal to 2.5 into 993. So we have to substitute this value in place of this log K2 by K1. We will get 2.5993 equal to EA into 2.303 into 8.314, we will get 19.147 into 700 minus 600, how much it is? 100 divided by 700 into 600. Okay, so EA we can calculate. Okay, after solving all these things, we will get what is the value of EA? 209.0 kilojoules per mole. Okay, so that is just direct substitution problems they will ask. You have to know the just what is that equation. Okay, this is the Arrhenius based on Arrhenius equation at two different temperature. Everything is given. We have to calculate only EA. Clear all of you? This is EA 209 into 209.0 kilojoules per mole. Problem is the rate of a reaction quadruples. That means 4 times it is increasing when the temperature changes from 293 to 313 Kelvin. Okay, temperature we increase from 293 to 313 Kelvin. The rate of the reaction increases 4 times. Okay, calculate the EA of the reaction. EA means what? Energy of activation or activation energy, assuming that it does not change with temperature. Okay, EA, it would we have to assume that EA it does not change with temperature. Leave that part, only we have to calculate EA. That means the temperature is increased from 293 to 313 Kelvin. Rate is increased, rate of the reaction 4 times increased. So we have to calculate EA. According to Arrhenius equation, we know log K2 divided by K1 equal to EA divided by 2.303 R T2 minus T1 into T2. In this EA we have to calculate. Okay, so here it is given the rate of the reaction is 4 times increases. Okay, so K2, K1 is the initial rate constant. After increasing the temperature, the rate of the reaction is increased 4 times. Okay, so can I take this K2 as for K1? Because the rate of the reaction increases 4 times, that means the rate constant is also increased 4 times. So K2 is equal to 4 K1. Clear? Once again I will explain, because it is given in the problem. When the temperature is increased from 293 to 313 Kelvin, the rate of the reaction increased 4 times. Okay, so K1 we have to consider as the initial rate constant. After increasing the temperature, the rate of the reaction is increased 4 times. That means the rate constant was increased 4 times. That is K2 equal to 4 K1. So K2 equal to 4 K1. Clear? So I will substitute these things here. So log K2 means 4 K1 divided by K1 equal to EA divided by 2.303. R means what? Gas constant, that is 8.314 into T2 means it is given 313 Kelvin minus T1 it is given 293 Kelvin divided by T1 into T2 or T2 into T1. This is 313 into 293. Okay, so here we have to solve this one. Log 4 K1 divided by K1 means K1 and K1 will cut, and log 4 we will get. What is the value of log 4? It is 0.6021. Substituting that value, 0.6021 equal to EA into 313 minus 293, how much it is? 20 divided by 2.303 into 8.314 into 313 into 293. Okay, so we have to calculate EA. So cross multiplication, EA equal to 0.6021 into 2.303 into 8.314 into 313 into 293. Just to solve it, divided by 20 we will get 52,863.33 joules per mole. What is activation energy? Okay, if you are converting that into kilojoules means what? We have to divide with how much? 1000. So can I write this one equal to 52.863 kilojoules per mole. Nothing is there. We have to divide this one. Joules we have to convert into kilojoules by dividing with the 1000. So what is the final answer in kilojoules? It is 52.863 kilojoules per mole. Okay, so clear all of you above. Okay, next is correlation theory of chemical reactions. It is very important. They will ask postulates of this theory. This year, last year exam also they asked. Okay, So according to collision theory, what are the postulates? We know we have to learn minimum 3 postulates, right? And this theory is proposed by Max and Lewis. And this theory is having mainly 5 postulates, and this theory is mainly based on kinetic theory of gas molecules. Last year we done kinetic theory of gas molecules. Okay, so what are the postulates means? According to this theory, they considers the reactant molecules as hard spheres, just like in solid state we explained. Okay, so the reactant molecules are considered as hard spheres. Then second means the reaction occurs when the molecules will undergo collision, or when the molecules will collide each other, then only what will happen? The reactant. So the reacting molecules are considered as hard spheres. The reaction occurs when the reacting molecules are collide with each other. That is the second postulate. For effective collision, the molecules should have a proper orientation and with a minimum amount of energy, that is known as minimum amount of activation energy, that is known as threshold energy. Last class it was there. What is threshold energy? Okay. So we know the molecules will undergo collision, then only what will happen? The reaction will happen and the products formed. Okay, so for effective collision, the reacting molecules or reactants will have a proper orientation. Proper orientation means suppose one reactant is here, the other reactant is next to that with a proper orientation. Then only what will happen? Reaction happen. Otherwise no reaction. Okay, so for effective collision, the reacting species will have a proper orientation and a minimum sufficient energy should be there. That energy is known as what? Threshold energy. Okay, then next point is with the proper orientation, the molecules, reacting molecules with the proper orientation only gives which one? Products. Okay, so the colliding molecules will have a proper orientation. That molecules only will lead to the formation of which one? Products. Otherwise, what is that? That collisions, it will not give which one? It will not lead to the formation of products. Thus, that molecules will bounce back. Okay, so the molecules with the proper orientation only gives the products. Other what is happening? That collision, there is no products molecules, only there is a bounce back. Okay, then the effective collision between the molecules leads to breaking the bond between reactants. Okay, during effective collision what will happen? The bond between the reactant molecules break, and what will happen? The bond between products molecules are formed. Okay, so during collision the bond between the reacting molecules is break and a bond between the products molecules are formed. So this is the main postulates. What are the postulates? First one is atoms of reacting species, they are considered as the hard spheres. Then the collision between the molecules leads to the formation of a react products. Okay, then there is no effective collision. Not all collision leads to formation of the products. Effective collision means the molecules will have a proper orientation and a sufficient amount of energy is known as which one? Threshold energy. Okay, so with the proper orientation only leads to the formation of which one? Products. Other, just the colliding molecules bounce back. Okay, then the last one is during effective collisions the bond between the reactant molecules is break, but the bond and a bond between the products molecules will form. That is the which one? Postulates. So we can explain this theory, collision theory, based on one example. It is given bromomethane. Bromomethane means, what is the formula of bromomethane? It is a haloalkane. That means alkyl part, alkyl group is there along with what is there? Halogen is there. That is why it is known as which one? Haloalkane. Here it is example bromomethane. We know which one is the methane? CH4. This is the methane. Okay. In that one bromine molecule is added. That is why it is known as what? Bromomethane. CH3Br. Bromomethane. One chapter is there, haloalkane. Okay, we will study detail. So bromomethane, your example is given. Bromomethane react with OH minus. OH minus means what? Hydroxyl group. Okay, OH minus ion, hydroxyl group or alcoholic functional group. Then what will happen is, two ways this reaction may happen: with the proper orientation of the reactant molecules, and one is in improper orientation of the reactant molecules. If the proper orientation means, what will happen is, First I will explain improper. Improper orientation means this is our bromomethane CH3Br. Okay, this is not properly oriented. So what will happen is what will happen? They will not undergo effective collision and they will not undergo reaction. Just the reactant molecules bounce back. That you can see, one is going this direction and the other one is going that direction, and there is no products. Okay, so without proper orientation or improper orientation means what? The collisions will not be an effective collision. Okay, so that is what will happen. The reacting molecules, they will just bounce back and there is no product is formed. But in proper orientation, we can see here these will react. They are in proper orientation, so we will get an intermediate complex. Okay, here you can see this is the OH group, right? Okay, so OH group, you can see the dashed lines. That is means there is a bond is forming. Here what is happening? Our Br bond is it start breaking. That is why this is also dashed line. Okay, carbon bromine bond, what will happen? It just start breaking. We know during effective collision what will happen? The bond between the reacting species or reactant start breaking. So here it is start breaking. Okay, but here it is start forming. Okay, that is why both I am showing. This is going, this is coming. So this is both is which one? Dashed line. So an intermediate complex is formed. Okay, so after forming that intermediate complex, there is no place, so I will draw here. Here is the arrow mark, this arrow mark. Okay, so this one will leads to the formation of our product, that is CH plus what is here? Br minus is gone. Br minus. Okay, so we got, this is an alcohol, that is known as which one? Methanol. Okay, because it is methane group. From methane group, one OH group is substituted, that is why it is methanol. Okay, so bromomethane is converted to which one? Methanol. Okay, if improper orientation means there is no product, but proper orientation means we will get a product. Okay, so according to this theory, there is an equation is there for calculating the rate of an equation. So rate equal to Z, okay, e raised to minus Ea by RT. Okay, if you are considering a reaction, A plus B gives product. Okay, A plus B gives products. A plus B gives product. Rate equal to, how we can write? ZAB e raised to minus Ea by RT. Okay, where Z is known as collision frequency. They will ask for 1 mark question. Define collision frequency. Collision frequency. So what is collision frequency? Means number of collisions per unit volume is known as what? Collision frequency. So here ZAB means it is what? It is the collision frequency for A and B. Okay, so generally generally we can write it as Z. Z equal to what? It is a collision frequency. That means number of collisions per unit volume. Number of collisions per unit volume is known as what? Collision frequency. Here, so just comparing this one with our Arrhenius equation. Arrhenius equation, K equal to A e raised to minus Ea by RT. Right. So this A and Z, this collision frequency is related. This A and Z is related. A means what? Arrhenius factor, and Z equal to collision frequency. To correlate more about which one the proper orientation, one more term is introduced in this equation 1, that is rate equal to P into ZAB e raised to minus Ea by RT, where P is known as what? Probability orientation probability factor. Orientation probability factor. Probability factor or steric factor. steric factor. So what is P? It is the orientation probability factor or steric factor. That means this P gives how the orientation of molecules in a reaction. Okay. So P into Z, comparing with Arrhenius equation, we can write here P into Z. P into Z equal to which one? Our A. Okay. Z was there. Okay. For explaining about the orientation, we introduce one more factor that is known as P. P equal to probability factor or steric factor. So comparing this equation to our Arrhenius equation, P Z we will give which one? A. Arrhenius factor. Okay. Where P equal to which one? Orientation probability factor or steric factor, and Z equal to which one? Collision frequency. Okay. So that is about which one? The collision theory. And one more thing, limitation of collision theory is there. The four limitations are there. First, they are considering the molecules, reactant species as which one? Hard spheres. But they are not telling about their structures. That is the first drawback. And second drawback or limitation they are telling is, they are calling this P as probability factor or steric factor. But they are not telling why it is known as a steric factor. That is the second thing. And the third one is the calculated value of rate constant according to this equation, their equation. It is very high, okay, compared to the measured value. The calculated value of the rate constant using this equation, calculated value of rate constant or rate using this equation is very high compared to the actual or measured value. So that is about the end of this chapter. So once again I will refresh the chapter from where we started. Okay. Once again the summary of this chapter I will write to you. First we started with which one? Average rate. Then instantaneous rate. First was which one? Average rate. Then instantaneous rate. Instantaneous rate. Okay. Then third was what? Order was there. Order and molecularity. Order and molecularity. Then very important, it was there which one? Integrated rate equation. Integrated rate equation for which one? Zero order and first order reaction. And along with which one was there? T half. Half-life for which one? Zero order and first order reaction. It was there. Then the influence of which one? Temperature on rate of equation. Arrhenius equation was there. Okay. Then now the influence of which one? Catalyst. Then the collision theory. Okay. That is about this chapter, girls. Thank you.